Japanese rail and wheels are extremely tough and wear-resistant, and both are highly praised throughout the world's railway industry for their reliability. The amount of time spent on their research and development has given rise to trusted manufacturing methods that are unique to Japan and respected worldwide. In today's program, we take a look at those tried and tested production methods and learn a few secrets about Japan's world-class rail and wheels. Much of the rail exported from Japan is harder and more wear-resistant compared to other conventional rail, and it's also known for its long life. The rails were tested on curved sections of an American transcontinental railway that operates long, heavy freight trains, and their durability was perfectly demonstrated. While conventional rails only lasted 18 months, Japanese-made long-life rails lasted nearly twice that, at 30 months. The USA's Transportation Technology Center also conducted durability tests, and again, the rails received the highest praise. This is a factory in Hiroshima Prefecture that manufactures long-life rails. Approximately 150,000 tons of rails are produced here annually, with over 70% being exported. An experiment using a steel ball was conducted to compare the relative hardness of conventional and new rail material. As you can see, there was a huge difference in the hardness of conventional and the long-life rail steel. The hardness of the long-life rail steel is a result of its unique chemical composition. The steel material used for these rails contains a hard white layer and a soft black layer. The manufacturer successfully created hard, wear-resistant rails by making the intervals between these layers just 1/4 of that in conventional rail steel. However, there were a few obstacles they needed to overcome first.
We were facing the issue of the rails being too brittle when we focused on hardness alone. When we thought about a solution, we decided to develop a rail that is both hard and tough.
In order to develop a perfect balance between hardness and toughness, research began on the chemical composition of the steel. In addition to iron, the properties of steel are affected by the relative amounts of carbon, silicon, manganese, phosphorus, sulfur, and other elements it contains. Of course, we can't disclose trade secrets on the program, but through careful manipulation of the steel's chemical makeup, the manufacturer discovered a formula that would result in a harder and much tougher rail. To measure hardness and toughness, hundreds of steel samples were made, each with minute adjustments or changes to the formula of chemical components. This is the machine used to carry out the experiment. Actually, the hardness and toughness of steel materials also changes greatly depending on the method of cooling. Hundreds of samples were tested using various cooling techniques. First, a sample is placed into the machine. Once the temperature reaches 1,000 degrees Celsius, various tests are carried out as the metal cools. The sample is subjected to the same stresses a rail would be expected to tolerate. Next, the sample is heat-treated, and then the hardness and structure is evaluated. These tests were repeated hundreds of times, which eventually led to the discovery of an optimum chemical composition and heat treatment method. This is the production line for the long-life rails. The steel passes through several mills and is gradually shaped into rails. After this, the heat treatment process begins. Unfortunately, we couldn't film any further. According to the information provided by the manufacturer, the cooling method is as follows. As the rail enters the heat treatment equipment, its temperature is above 800 degrees Celsius. The rail is then cooled rapidly. This manufacturer uses an air cooling method instead of water. The important factors are the force of the air, its direction, and the timing of the blasts. Depending on the part of the rail, the force of the air is slightly changed. This precise method relies on technology only Japanese manufacturers utilize at present. This is how a long-life rail is produced. These rails are often used overseas for lines with trains hauling heavy loads to reduce the cost of maintenance and replacement. In the future, this manufacturer plans to produce rails according to the precise demands of the railroad companies.
It has become impossible to satisfy all the railroad companies because in the end, each has different requirements and expectations for their rails. In the future, we would like to propose a specific type of rail that would be best for each client. That's the level of technology we're aiming for.
This wheel manufacturer in Osaka is the only one of its kind in Japan. Approximately 200,000 wheels are manufactured here every year, and around 50% of them are exported. The wheels are exported to 17 countries and regions around the world, such as Germany's high-speed railway, the ICE, Union Pacific freight trains operating in North America, the subways of New York City, and railways in Asia, the Middle East, and Africa. As you can see, Japanese wheels are being utilized by all types of railways. Wheels made in Japan are praised for having high durability. This manufacturer has been making wheels since 1920. In 1926, a loop line was created within the factory to conduct wear tests on the wheels. They've long been dedicated to research and development, and since the latter half of the 1960s, the company has been producing world-class wheels. The first feature of highly durable Japanese wheels is that they are wear-resistant. At the Railway Technical Research Institute in Tokyo, wear resistance evaluations are conducted on wheels brought in by manufacturers. Just as with rail manufacture, the key to wear resistance lies in the chemical composition of the steel.
一番大きな違いはですね、やはり炭素量になるかなというふうに考えています。成分が少し違うというところになると思います。それによって強度が硬さが変わってくるということになります。
Smelted iron ore produces pig iron, which also contains amounts of carbon, manganese, silicon, phosphorus, sulfur, and other elements. Elements other than the carbon are then removed from the iron and the amount of carbon is adjusted. Just the right amount of carbon makes the metal harder and more wear resistant. Too much, on the other hand, makes it brittle. The final steel material is produced with a carbon content of 0.6 to 0.75%. This range is considered the optimum value for manufacturing wear-resistant wheels. The steel produced at the steelworks is then transported to the wheel manufacturer. A second feature of highly durable Japanese wheels is that they are crack-resistant, or tough. If the toughness of the wheel is insufficient, deterioration such as shelling may affect the surface of the wheel, or thermal cracks can appear due to the heat produced by the brake shoes. These are just some of the ways that wheels can be damaged. The toughness of a wheel can differ greatly depending on the manufacturing method. There are two methods used when manufacturing steel components: casting and forging. Casting involves pouring molten steel into a shaped mold. Then, as the metal cools, it takes on the desired shape. It is inferior in durability, but because it's relatively cheap and quick, it's more suitable for mass production. Manufacturers in North America mainly utilize this method. On the other hand, forging is a method of molding steel by compressing it into a template. Since it uses a large-scale press machine, it's slower and costs more. But metallic density is also higher, so crack-resistant wheels can be produced. Japanese wheel manufacturers use this forging method. The main reason this manufacturer can create world-class durable wheels is their forging method. Steel from the steelworks is heated up to 1,250 degrees Celsius. The steel is then rounded using a 9,000-ton press. Then the mold is changed, and on the second press, the steel begins to resemble a finished wheel. Next, a wheel rolling mill shapes the wheel to a predetermined size. Finally, and the key part of the process, a rotary forging press further elaborates the wheel.
Because the rotary forging press rotates, the upper mold is slightly tilted. This enables us to produce wheels with extreme uniform metallic density. Then, after forging the wheel, we make final adjustments as the steel cools. It's what we do during this cooling process which ultimately dictates the hardness of the wheel.
This manufacturing process produces wheels that are both wear-resistant and durable. This manufacturer produces more than 200,000 wheels a year, while its affiliated company in the US produces a further 300,000. Between them, they currently manufacture approximately 10% of the world's train wheels.